Are there any questions on the homework? You good? Questions on the homework? What we're looking at today is a matrix. A matrix is a rectangular arrangement of numbers. The dimensions of a matrix are rows and columns, m rows and columns. And the dimensions are m by n. So here, this matrix has 2 rows and 3 columns. So we call it a 2 by 3. 2 rows, 3 columns. So it's a 2 by 3. Questions on this here? All right. A matrix derived from a system of linear equations, each written in standard form and the constant terms on the right. So x, y, z on one side, numbers on the other, or x, y on one side, numbers on the other, is called an augmenting matrix. Now, here it's already set up. Each equation, x, y, z, is on one side, numbers are on the other. So if we look at the first row, 5, 3, negative 2, 1. 5, 3, negative 2, 1. The number in front of x would be 1, 2, 3, negative 1. 1, 2, 3, negative 1. And the last one, 3, negative 4, 1, 10. 3, negative 4, 1, 10. All right, guys, let's focus up here. We can talk about the calculator in a minute. And that's how we would do this here. Now, let's do one together. So our first example, right here. Writing an augmented matrix for the system, then state the dimensions. So when we write an augmented matrix, we need both equations, x, y, z, or x, y in this case. So we don't need the calculator quite yet. So we need both of these in xy form. Is one of these not in xy form? Well, the first one, yes. So we need to rewrite the first equation. The variables are on the same side, but they're out of order. We need the 2x first. Well, we can move the negative 2x to the front. Then we would have plus y is equal to 1. So the first one here, we just need to reorder our variables so that we have x, y, and if we had z, it would come third. Questions on this here? Now the second equation is already in the correct form. X plus 3y is equal to 12. Questions on anything we've done so far? We good with this here? So to write this as an augmented matrix, first thing we're going to do is start off with a bracket. And across the top, we're just taking the numbers in front of our variables. We're just taking the numbers. So the number in front of x is negative 2. Our number in front of y is 1. And then we have on the other side of the equal sign 1. So the first row is negative 2, 1, 1. Questions on this so far? Let's look at the second row. The number in front of x would be 1. The number in front of y is, and our last number is, okay. So we have our augmented matrix. Now we need to state the dimensions, rows by columns. So how many rows do we have here? 2. How many columns do we have? 3. So this here would be a 2 by 3. That's it. That's all we have to do. Be ready for the next one. Write an augmented matrix for the system, then state the dimensions. The second equation, 2x minus y equals 5. We're good. We have x, y, number equals number. First equation, we have yx. We need to rewrite it. We need to switch those two. So we'd have 4x. So it would depend on the sign in front of it. So here the sign is positive, so it'd stay positive. 3y is also positive. So we have plus is equal to 13. Now the previous one, our 2x was negative, so it was negative 2x plus y. Here they're both positive, so we'll have 4x plus 3y. So we have both equations and x, y equals number. So now let's take the coefficients. The number in front of x is 4. The number in front of y is 3, and it's equal to 13. So our first row is 4, 3, 13. Second row, number in front of x is 2. Number in front of y, negative 1, and it's equal to 5. So our second row is 2, negative 1, 5. Now we need to state the dimensions. So how many rows do we have? 2. How many columns? 3. So the dimensions are 2 by 3. 2x 3. Questions on this here? Let's look at this one here. So we want to write an augmented matrix for the system and state the dimensions. Well, the first equation, z is on the wrong side. So we're going to have to fix that. So we can rewrite the equation here out to the side because we're going to have to do So what we need to do is move the 2z from one side to the other, yes? How can we move it from one side to the other? We can add it to both sides. I can add 2z to both sides. Because on the left-hand side, we'd have 3x minus 4y plus 2z is equal to 7. Well, our negative 2z plus 2z is 0. Okay. Do we have that equation fixed? Okay. If we want, I'm just going to rewrite it above it. 3x minus 4y plus 2z is equal to 7. We can make our augmented system now, yes? So our first row, the number in front of x is 3. Number in front of y is negative 4. Number in front of z is 2, and then it is equal to 7. I wait to do the second bracket until I finish putting the first row because it gives us a good spacing. Because all the ones below it should have 4 numbers. Now the second row, the number in front of x is 9. The number in front of y is 3. The number in front of z is 0. Since there's no z, it is 0. Anytime we have a variable missing, it is 0. Now, if it is not listed, we don't have to put it at all. So if we look at the previous one, is there a z? No. So there's no reason to put zeros for z because z did not show up in any of the equations. If we look at the one we just did, does at least one of the equations have z? Yes, which means we have to fill in 0 for the others. If the variable shows up at least once in one of the equations, we need it in the others. And then this second one's equal to 3. The last one, 2, x is 2, y is 4, z is -1, and it's equal to 2. Now what's the dimensions of this one here? 3 by 4. Questions on anything we've done so far? We like these so far. Okay, you ready to look at the next one? All right, so which equation do we have to fix? None. The first one's already x, y, z, yes? Second one's x, y, z. Third one is x, y, z. We don't have to do anything to any of them. We can go straight into the augmented matrix, and across the top we would have 8, -3, 1, 5. The second row would be 2, 1, 4, 2. And lastly, 9, -7, -3, -6. And this is a 3 by 4. 3 rows, 4 columns, 3 by 4. How do we feel about these here? We feel good with writing augmented systems. Do we need to see another example of writing an augmented system? X, Y. I mean, for the most part, it's just getting all the variables on the same side and in the correct order. Let's look at this here. Many technology tools have matrix features that you can use to solve systems of linear equations. The augmented matrix in example 2. Rewritten in reduced row echelon form is shown below. Observe that the solution to the system is this here. Well, if we look at this matrix, our first column was x, our second column was y, and our third column was z. And this is equal to our number, our solution, yes? That's how we set it up. So the first one, we have 1x plus 0y plus 0z is equal to -1.4. That's what the first line's telling us if we go back the other way, yes? Do we really write 0y or 0z? No. So this is really telling us what? X is -1.4. The second one, we don't have an x, we don't have a z. It's just telling us y is 5.2, and the last one, z, is 16. So our solution is -1.4, comma 5.2, comma 16. So for this system, this is our solution. All right. Now, solving a system using technology, right? An augmented matrix from a linear system. Enter the augmented matrix, use reduced row echelon form, and then interpret the results. Well, let's do that here. So the first thing we need to do is rewrite this as an augmented matrix. So our first equation, x plus y plus z equals 2. In augmented matrix form, it would be 1, 1, 2. The next one would be 2, 3, 1, 3. And the last one would be 1, 1, -2, 6. And the dimensions for this are 3 by Okay. Questions on this so far? Okay. Let's get the calculator. First step's turn it on. Batteries are low or dead? Okay. Yep. That is not uncommon. I do have to end up replacing all these batteries by the end of the year. So we'll go through probably 80 plus batteries a year. All right. We got them turned on, yes? First thing we're going to do is go second matrix. Second x to the negative 1. Also, by the way, there is a key press history down here at the bottom, so you can follow along there. So second matrix, because second, whenever you hit second, everything in blue, all the blue above the number or buttons, is what it will do. So we're doing second x to the negative 1. Were we all able to get to this here? Now we need to put the matrix in. So to do that, we're going to go over to Edit. So at the top of the screen, there should be a black box around Edit. So this here lets us edit the matrix or put in the information for each matrix. And the one we're going to put it into is matrix A. So it should already have a black box around number 1. So hit enter. You might not have an exact screen like this. It might be 1 by 1, but the first thing we need to do is put in the dimensions. And what were the dimensions of our matrix? 3 by 4, so we'll type 3, enter, 4, enter. You can use the arrows to move around in this here. Enter also works, so type the number in and then hit enter. So our first line of this here is a 1, 1, 1, 2. We're just going to type in our augmented matrix. Our next one is 2, 3, 1, 3. And we have 1, negative 1, negative 2, negative 6. So we're typing the whole augmented matrix in. We get that typed in. Second matrix. Yep, nope. Over to edit. Enter. And I need to type that augmented matrix in. Enter. Yep. Has everybody been able to get it typed in? Yes. Once you finish getting it typed in, second quit, second mode. So second quit or second mode. You should get back to the home screen. Okay. Now we're going to apply our calculation to it. We need to do the reduced row epsilon form. Now to do that, our first step is going to be second matrix. Now we're going to cursor over 1, 2 math. All of these here are different type of operations we can apply to matrices. The first one's determinant. I don't know what the second one is, but the third one is dimensions. So if you do DIM matrix A, it will tell you the dimensions of matrix A. I don't see a whole lot of point in that because we had to type the dimensions of matrix A to be able to put the information in. So it's just going to tell us what the dimensions are. So what we want to find is RREF. So you can scroll up or down. We're looking for RREF. RREF is what we're looking for. So scroll up or down, RREF. And once you get it selected next to it, hit enter. We're all able to get to this screen, yes? Okay, now at this point we need to put the matrix in because we need to tell it what we're going to apply this reduced row epsilon form to, this RREF. Now to get there, we're going to go second matrix again. Now this first one that's been pulled up each time, this first list lets us recall the matrices and be able to use them. Well, we put it into which one? Matrix A. It's already selected, so go on and hit enter. So we should have RREF parentheses and then our matrix A. Hit enter. We all have something like this here. So that diagonal of ones, and the last column is our solution. The first one's our x, the second one's our y, third one's z. So x is -1, y is 1, z is 2. So our solution is -1, 1, 2. So the solution for this system of linear equations is -1, 1, 2. Questions on this here? So I do have all the steps written out are included in your note sheet right there. It's kind of a simplified version of it, but it is there. We ready to do another one of these? All right. First thing we need to do is write an augmented matrix. So we have what? 2, 3, -1, 15. Then we have 3, -9, 9, -12. Last one, 4, -3, -1, 19. And this here is still a 3 by 4. All right. Once we get that written up, we can go to the graphing calculator. We can do second matrix. We can go over to edit and hit enter. It is still a 3 by 4. But this time we have 2, 3, -1, 15. 3, -9, 9, -12. 4, -3, -1, 19. Once you get the whole thing typed in, second quit. Second mode, second quit. From here, we're going to go second matrix. This time over 1 to math. Questions? It is right. So it is the numbers in front of it. So the last column. So 4, -3, -1, 19. Mm-hmm. So if you've got it to this point, so if you have it typed in, we go second matrix, math. Now we're trying to find what? RREF. Once you find it and have it selected, hit enter. And lastly, second matrix. And since we want matrix A, we hit enter. If we wanted matrix B, we would go down one and hit enter. And hit enter one more time. So our solution for this is what? 5, 1, negative 2. Mm-hmm. Yeah, so REF, or are you just trying to get matrix A? Enter. Yep, so hit enter, or go back up one. So, second matrix. It's already, A is selected at the beginning, so just hit enter. Enter. Huh? That's a cricket. Yeah, that's a cricket. That's a camel cricket. Yep, that's a camel cricket. Questions on this here? Let's do one more of these and then I think I'm missing number 5. Yes. Or no, this is, wait, what? So we have that. Yeah, these are out of order. Yeah. All right. Let's do this here. So our augmented matrix for this here would be what? 1, 2, negative 3, negative 2. 1. And this is still a 3 by 4. So we can go to the calculator. And our first one is second matrix. We go over to edit and hit enter. And our matrix is still a 3 by 4. This time our first row is 1, 2, negative 3, negative 2, 1, negative 1, 1, negative 1, 3, 4, negative 4, 4. And once we finish getting it typed in, we're going to do what? Second mode, second quit. All right. You don't want to see a little shortcut here. If we scroll up to, we have RREFA selected, yes? If I hit enter, it brings it back down. Y'all have done this before, yes? Is matrix A the same matrix as what it plugged in the last time? No, we changed it, right? So if I hit enter again, it'll apply the new one. Because once we type it in once, we can just go back up, grab it, and redo it again. So the solution for this here is 0, 5, 4. Matrix. 2, 4. Negative 6. Okay. All right, guys. I changed what matrix A was a little bit. Now, if we look at this here, we do have decimals. We don't have that diagonal of 1s, yes? But the last row is what? 0, 0, 0, 1, yes? This is no solution. Because having that last row, 0, 0, 0, 1, we got stuff up here. All this is saying is that 0 is equal to 1. This is no solution. All right. What do you think infinitely many solutions would look like? The last row would be what? The last row is all zeros. So 0 is equal to 0. So it still will do infinitely many and no solution. We just have to know how to interpret the graph. And what those two lines above it are saying is kind of how the x and y would work. But we're not too focused on that there, because again, if it is no solution, 0 equals a number, we just say no solution. If it's infinitely many, we're not going to define it based off the equations. We're just going to say infinitely many. We need to see another example of one of these. We feel good with these. Homework 3 through 8. So you're writing the augmented matrix and stating the dimensions. 11 and 12 are correct the error. So again, two parts. You're going to state what error they did. Most likely it's going to be switching in x and y. They didn't fix it, so on and so forth. And then you have to write it in the correct form. So you'll end up rewriting that one twice because it is the same matrix. 13 through 19, solve the system of linear equations. If we run out of time before the end of the hour, you won't have time Thursday or Friday to work on it in class with those there.